Alright guys, welcome to Pre-algebra 3.4. We are solving inequalities using multiplication and division. So before we get too heavy into today's stuff, I just want to kind of show you something I think is kind of cool. It helps us get ready for what we're doing today. Let's say we had a statement that it was 2 is greater than, we'll say 8, okay? 2 is greater than 8, or sorry, 2 is less than 8. 2 is less than 8. We would say, yeah, that's a true statement, right? What happens if you multiply one side by 4? Or what do you have to do if you multiply one side of an equation or an inequality by 4? We have to multiply the other side by 4, right? And so that would get you right there, 8 is less than 32. So we started with 2 is less than 8, which is a true statement. Now we have 8 is less than 32. Also a true statement, right? If I had... say 3 is greater than 0, right? And that's a true statement, right? 3 is greater than 0. If I take the left side times negative 2, I'd have to take the right side times negative 2 as well, because you have to, whatever you do to the left, have to do to the right. So negative 2 times 3 is negative 6, is greater than 0 times negative 2, which is 0. So negative 6 is greater than 0, right? Oh. Wrong. Interesting. What do you think happened there? Up here, I had a true statement, 2 is less than 8. I took both sides of this inequality times the same thing, times 4, and I still got 8 is less than 32, which was still a true statement, just like the original. Well, here I had a true statement, 3 is greater than 0, right? It's true. I took both sides of this inequality times the same thing, times negative 2 and times negative 2. But when I did that, 0 times negative 2, I got 0, and this was 6, negative 6, so negative 6 is greater than 0. I took both sides of the inequality times the same thing, but this time I got a false statement. How is that happening? Well, we're going to get into that more in a minute. Sorry, this is problem number 1. Moving on to item number 2. Alright, so let's say we have 2x is less than or equal to 4, and I say we're going to solve this inequality. Well, how do we do that? Well, the same way we would solve an equation. Alright, 2 is being multiplied by x, but I need x to be by himself, right? So how do I get that 2 out of there? Well, I divide by 2, but if I divide the left side by 2, I have to divide the right side by 2. And 2x divided by 2, those both cancel or become 1s, which would be like saying 1x over 1, which is just the same as saying x. So we have this part of our answer. And then 4 divided by 2 is 2, okay? Now, I divided by positive 2 and positive 2, so I'm not going to change my sign. It's going to stay the same. It was less than or equal to there. It's less than or equal to down here, okay? So you might be thinking, well, yeah, why would you change the sign? Well, because of what we did first, okay? So the multiplication property of an inequality says that when you multiply, we'll type this out. Oh, that's too big. All right, so when you divide both sides of an inequality by a positive number, you produce an equivalent inequality. And what does that mean? Well, what that means is, like here we started with 2x is less than or equal to 4. I divided both sides by a positive number, and I got x is less than or equal to negative 2. This is saying the same thing as this, except this is a little more simplified, okay, or it's solved, all right? But it produces an equivalent inequality, all right? However, when you divide both sides of an inequality by a negative number, you must reverse the direction of the sign to produce an equivalent inequality, okay? So let's try this one. Negative 3x is greater than 12, all right? So again, I'm solving this inequality, but whatever I solve it to, it needs to be equivalent to what this is, all right? It's going to take a different form, but it needs to be equivalent. So you would probably look at this and say, oh, x is being multiplied by negative 3, so let's divide by negative 3. Okay, now we are dividing both sides of an inequality, so divide the other side by negative 3. So what happens? Well, the negative 3 over negative 3, those become 1s, or they cancel either way, and you're left with x. right? And 12 divided by negative 3 would get you negative 4. But here's the thing. We have divided both sides of an inequality by a negative number. Okay? And when we do that, we must reverse the direction of the sign. So what was greater than now becomes less than negative 4. And there's our answer. Now let me prove to you why that has to happen, why you have to change the direction of the sign. X is less than negative 4. So let's pick a number that's less than negative 4. All right, we're going to do negative 10. It's significantly less than negative 4. So I'm going to rewrite my original. And I'm going to plug in this negative 10 for x. So now I would have negative 3 times negative 10 is greater than 12. So what's negative 3 times negative 10? Positive 30 is greater than 12. And that is a true statement. That checks out. Okay. But what if I hadn't reversed the sign? Okay. What if I hadn't reversed the sign? What if I had said, negative 3 divided by 3 is just 1, or it cancels. I'm left with x. 12 divided by negative 3 has negative 4, and I keep the sign going this way. Okay, now again, I'm writing bad here because this is not the answer. This is the answer, but let's just see what happened if we didn't reverse the direction of the sign. All right, what is some number that's greater than negative 4? Well, an easy one would be 0, right? So let's rewrite the original. Negative 3x is greater than 12. Let's plug in that 0 there for x, so we're checking our solution. Negative 3 times 0 is greater than 12. Well, negative 3 times 0 is 0. It's greater than 12. This is a false statement. Of course, 0 is not greater than 12. So if we hadn't reversed the sign, if we had gone with this as our answer, we would get false statements if we started trying different solutions like we did here. You have to reverse the sign. Okay? Now the same thing stands when you are multiplying or dividing an inequality. So if I had m over negative 3 is less than or equal to 10. All right, so what that says is there's some number divided by negative 3 that's going to be less than or equal to 10. And some number is actually going to be multiple numbers. So just like equations, I would solve this thing by saying, m is being divided by negative 3, so let's multiply both sides by negative 3. Technically over here I can make this negative 3 over 1. I don't have to, but I can. And what that becomes is those two cancel, leaving me with 1 and 1. So it would be 1 times m over 1 times 1. So 1m over 1, which we know is the same as just saying plain m. And that's, let's see, well, 10 times negative 3, that would get you negative 30. So where does our sign go? Well, it was pointing to the left, right? But because we multiplied by a negative number, I have to reverse the direction, and now it needs to point to the right. M is greater than or equal to negative 30. Now what I want you to do is I want you to plug in some number that is greater than negative 30 in for m and see if you get a true statement. So pause the video and try that. Okay, so I'm going to pick some number that's greater than or equal to negative 30. I'm going to pick the easy one. Okay, 0. Alright, so I'm going to plug in 0 into the original. The original was m divided by negative 3 is less than or equal to 10. If I plug that 0 in there, I get 0 divided by negative 3 is less than or equal to 10. And 0 divided by negative 3 is just 0 is less than or equal to 10. And I get a true statement. Now, I guarantee you that if you plugged in a number that was greater than or equal to negative 30 for m, and you did your arithmetic right, that you got a true statement also. Okay? And if you didn't, go back and look what you did, mark it, we can talk about it in class, however you want to approach that, all right? Now, the question becomes, what if you have something like this? Say 4y is greater than negative 20. Okay. Well, if we're going to solve that, we would divide by 4, right? Because 4 is being multiplied by y, so we're going to divide to break up that multiplication, but I have to divide by 4 here as well. So we know that this is just going to become plain y, and then negative 20 divided by 4 is negative 5. Now the question is, does my sign switch? Well, keep in mind, I divided by a positive number, right? 4 was doing the work here. He was doing the dividing. Negative 20 was being broken up, but he wasn't the one doing the work. Okay, 4 is the one doing the work here. So the sign actually stays in the same direction because I'm not dividing by a negative. I was simply taking a negative number and dividing it. Okay, now that might be a little confusing, but you got to keep it straight. Okay, so let's do a couple practice problems. I'm going to kind of turn you loose here. Oh, and I haven't been numbering these. Let's just call this problem number 3. Okay, if I had 2x greater than negative 240, and here I have m over negative 4 less than or equal to negative 16. I want you to solve both of those and then play the video when you're done, see what you get. Alright, so I hope here you divided by 2 and divided by 2, and you got x. Let's see, negative 240 divided by 2, well, it's definitely going to be negative, and 240 divided by 2 would be 120. Now the sign is going to stay the same, pointing in the same direction, or it's going to stay the greater than sign because I'm not dividing by a negative. Remember, 2 is the one doing the work, and he is positive, so the sign is going to stay the same. Now here, though, I'm going to multiply by negative 4 on both sides. Okay, and what happens on this side? They cancel and become just plain m. Negative 16 times negative 4, well, that's going to get you, negative times a negative is a positive. Okay, and 16 times 4 is going to get you 64. All right, 60, there we go, 64. Now, what about my sign, though? Well, let's see, what was doing the work here? Well, it was the negative 4. I was taking both sides of the equation times a negative number, and when you do that, it means flip the direction of the sign. M is greater than or equal to positive 64. Okay, so what we can do is we can just try, just because when we multiply by a negative, I like to just check my answer because it's a little more complicated. What's a number that is greater than or equal to 64? Let's pick an easy one, 100. So I'm going to say 100, rewriting the original, but instead of m, I'm plugging in 100. Divided by negative 4, less than or equal to negative 16. Is that true? Well, 100 divided by negative 4 is negative 25, and that is in fact less than or equal to negative 16. It's true, so we know that we did our work correctly. Alright, so you are going to pack for vacation, and rather than pack the essentials, what you have decided to do is pack just a bunch of bags of Starburst into a large garbage bag that weighs practically nothing. So the garbage bag doesn't weigh anything for today's purposes, right? So you're filling this garbage bag full of bags of Starburst. So the airport has a weight limit, though, on bags, and they say that they and their contents can't exceed 50 pounds. Each bag of Starburst weighs 40 ounces. So what we want to do is we want to write and solve an inequality for the number of bags of Starburst that you can pack. Now, what's our first problem we see here? Well, I was talking about pounds here and ounces here. That's an issue. So we are having to obey the rule that the airport has, and they state the rule in pounds. So I think we should make ounces into pounds here. Now we know that, hopefully, 1 pound equals 16 ounces. So the question is, how many pounds are in 40 ounces? Okay, well, we can do a little bit of cross multiplication here. 1 times 40 is 40 equals 16 times question mark. Well, what do we do when we don't know something? Well, we put in a variable there, so we're going to use the variable x instead of the question mark. So 16 times x is 16x. So now we just divide by 16. Divide by 16, here we're solving an equation. X equals 2.5. Okay, so how many pounds does a bag of Starburst weigh? It does weigh 40 ounces, but we're going to also say, instead of that, we're going to use 2.5 pounds. Okay, so it's 2.5 pounds per bag. So what inequality can we set up here? Well, so we have a limit, right? So we're limited to something. That's 50 pounds. So remember when we were solving equations and I said if you see a total, take that total and set it equal to the things that get you to the total. Well, in an inequality, if we see a limit, okay, and our limit is 50 pounds, we're going to write that limit. We're going to put a sign in between it and the things that bring you up to that limit. Okay, so 50 is the limit, and the contents of the bag and the bag itself have to be less than or equal to 50 because it cannot exceed 50 pounds. So we would use the less than or equal sign, but we got to put it this way. So it actually is the greater than or equal to sign, and I'll show you why in a sec. Okay. So how do we get to the limit of 50 pounds? Well, our bag doesn't weigh anything because it's just a garbage bag. It practically weighs nothing. So what we're going to do is say 50 is reached by the starbursts, right? Okay, so but how do we kind of write that? Well, we know the starbursts weigh 2.5 pounds, but per what? Per bag. And when we say per bag, I mean 2.5 multiplied by the number of bags. Now this is why the sign is pointing here, because if I reverse these things and I do 2.5 times b on this side and 50 on that side, here the sign was pointing to the 2.5, still need to make it point to the 2.5. How this reads, which is the same as this, is 2.5 pounds per bag, okay, of starburst has to get you less than or equal to 50 pounds, which makes sense because our limit was 50 pounds. So in order to solve for b, which is the number of bags of starburst I can bring, I need to divide by 2.5 and divide by 2.5, and there I get b is less than or equal to 20. Okay, b is less than or equal to 20. So again, what does that mean? Well, again, B stands for the number of bags of starburst I can bring. So what this says is, you know what, I could bring 20 bags of starburst if I want. I could bring 19 bags. I could bring 1 bag of starburst, but I definitely can't bring more than 20 bags of starburst. All right, guys, so there you go. That's all I have for you today. Look forward to seeing you in class.